NASA. NASA and the U.S. Navy were busy recently preparing for tests scheduled off the coast of San Diego, California. Crews will run through the procedures to recover NASA's Orion spacecraft from the ocean following its water landings from deep space missions. Kennedy Space Center, Johnson Space Center, and Lockheed Martin Space Operations are all involved in the recovery effort. During a July 31st briefing at NASA headquarters, agency officials announced that 7 science instruments out of 58 proposed have been selected to be part of the next rover NASA will send to Mars in 2020. The Mars 2020 rover will be a new version of the Curiosity rover currently operating on Mars, with more sophisticated hardware to conduct unprecedented science and exploration technology investigations, including geological assessments, potential habitability of the current environment, and directly searching for signs of past life on the red planet, something no previous Mars mission has done. NASA's Opportunity Mars rover now holds the off-Earth roving distance record after surpassing 25 miles of driving on the red planet since 2004. A 157-foot drive on July 27th put Opportunity's odometer at 25.01 miles. The previous record was held by the Soviet Union's Lunokhod 2 rover on the Moon. Opportunity, Curiosity, and the planned Mars 2020 rover are part of NASA's Mars Exploration Program, which also will prepare for a human mission to Mars in the 2030s. The Intelligent Robotics Group at NASA's Ames Research Center recently conducted the first field test of the newly updated K-REX rover in the Basalt Hills near California's Central Valley. The testing, funded by NASA's Space Technology, Science, and Human Exploration and Operation Mission Directorates, is designed to prepare for future NASA robotic exploration missions, including improved mobility over difficult terrain and remote control technologies.
Allumage des 2 EAP et décollage.
The European Space Agency launched its 5th and final automated transfer vehicle to the International Space Station from Kourou, French Guiana on July 29. The ATV-5 cargo spacecraft, named Georges Lemaitre after the 20th century Belgian astronomer, is scheduled to complete its 2-week journey to the ISS on August 12, with some 7 tons of food, fuel, and supplies for the Expedition 40 crew on board ISS. The first flight of an ATV was in March 2008. NASA has been out in the community using science, technology, engineering, and math, or STEM, to stimulate young minds just in time for back to school. Langley Research Center's recent Technology Day at the Virginia Air and Space Center featured more than 24 exhibits showcasing Langley's technology development in support of NASA's deep space exploration, science, and aeronautics missions. Meanwhile, a similar event hosted by Glenn Research Center at Cleveland's Great Lakes Science Center featured NASA Chief Technologist David Miller, astronaut Doug Wheelock, and Glenn Center Director Jim Free. It included presentations about the important role of Glenn technology in the past success of the Apollo program and how technology will enable NASA to make the next giant leap in spaceflight, sending astronauts to Mars. And that's what's up this week at NASA. For more on these and other stories,
what's up for August? Mars and Saturn pair up at sunset, and Venus and Jupiter before dawn. Hello and welcome. I'm Jane Houston Jones from NASA's Jet Propulsion Laboratory in Pasadena, California. 2 planetary conjunctions are visible to the unaided eye everywhere this month. Venus will be visible alone at dawn, low on the eastern horizon for the first week of the month. Then a week later, look for Jupiter just below brighter Venus. The Moon joins the 2 planets on August 23rd, making a pretty triangle in the morning sky. A dramatic close pairing of Mars and Saturn unfolds all month long. On August 1st through 4th, notice bright Mars in the southwest sky between fainter Saturn on one side and Spica on the other. The Moon hopscotches through the 3 objects each night, moving from the right of Spica on the 1st of August to the left of Saturn on the 4th. By the end of the month, swift Mars is to the lower left of Saturn, and the Moon joins the pair on August 31st. The Milky Way of summer comes into view as the sky darkens an hour or 2 after sunset. On the night of August 12th and 13th, the Moon is visible all night long, competing with the peak of the Perseid meteor shower. But don't let that big bright moon deter you from a fun sky watching and Perseid meteor watching night. The brightest meteors will be easily visible despite the moonshine. The Perseids are visible at impressive rates of up to about 20 per hour for 2 weeks before the peak and a week afterwards. That gives weekend campers and stargazers a good opportunity to see plenty of Perseids on August weekends through the 17th. Aim your binoculars at the Big Dipper and then star hop to Polaris and on to the right or east to the nearby W-shaped constellation Cassiopeia. From there, keep scanning right and you should be able to spot the Andromeda Galaxy with your binoculars in the nearby constellation Andromeda. You can learn about how NASA studies galaxies, meteor showers, and about all of NASA's missions at www.nasa.gov. That's all for this month. I'm Jane.
Welcome to Space to Ground, your weekly look at what's happening on board the International Space Station. I'm Nicole Cloutier-Lemasters. Right now, 7 tons of food, fuel, and supplies are bound for the space station. The European Space Agency's 5th and final automated transfer vehicle launched Tuesday night from French Guiana. ATV-VI, named for the father of the Big Bang Theory, Georges Lemaitre, is currently on a 14-day trek to the station with docking scheduled for August 12th. NASA astronauts Steve Swanson and Reid Wiseman were back at work with more spacesuit maintenance. The duo performed water leak inspections and a scrubbing of the suit cooling loops. They also measured conductivity of water samples taken from the loops to ensure they meet operational specifications. Swanson then collected tools in preparation for the upcoming Russian and U.S. spacewalks. 2 U.S. spacewalks are planned for the end of August for relocation, replacement, and reconfiguration tasks. Last week, the crew set a record for how much time they dedicated to science investigations. Typically, ISS crews are scheduled for around 40 hours of research per week, but they doubled that last week when the crew spent more than 83 hours on various experiments, from Skin B, which studies the aging of skin, to the 4 Shoes experiment, which helps optimize exercise sessions in microgravity. To learn more about how ISS research benefits life on Earth, visit nasa.gov/station-benefits. And we
As you get farther away from the sun, the temperature goes up. Now this is counterintuitive. It's like if you're trying to heat a marshmallow on a fire, you put the marshmallow closer to the fire to heat it up, not pull it farther away. This has been a mystery for quite a while. According to the nanoflare heating theory of the solar corona, there are very many low-energy nanoflare heating events. Energy is released in a nanoflare. It heats the local plasma to a very high temperature, around 10 million degrees, and there's such a small amount of this very hot plasma that we can't see the individual nanoflares. But as you cool down through the 2 million degree range, which happens fairly quickly, and as many of these events occur, we end up seeing the 2 million degree solar corona that we're used to. One of the objectives of the UNIS flight was to address this. UNIS is an acronym for the Extreme Ultraviolet Normal Incidence Spectrograph. It's an instrument that we fly on a sounding rocket out of White Sands Missile Range, New Mexico. It reaches an altitude of about 320 kilometers, which is about 200 miles. We record about 6 minutes of observations of the sun, and then the instrument parachutes back down into the desert where we can retrieve it. Basically, it's 2 separate instruments, 2 spectrometers pointed in the same area of the sun, so that we can be observing a very wide wavelength range. Each of these channels is very rich in emission lines. There are many lines from many different ionization stages of lots of different elements. For the purposes of this work, we're interested in the iron-19 and the iron-12 emission. We can see faint emission at those temperatures that provide the further smoking gun evidence for the nanoflare heating theory. So this is very exciting for astronomers and people who are trying to diagnose what's going on in the sun's atmosphere.